Well, good morning, and we're going to continue our exploration of structures and other interesting things about them, structures, objects, classes. We're going to discover some interesting uses of references, hopefully today and next week. So, plenty of topics. So, just to underscore what I expect you already know, I think we can say that we discussed a set of interesting C, C++ features, and one of them was the pointer, right? So when we say integer x equals 0, right? This is an integer variable in whatever scope it was created. Then we can say integer pointer p equals address of x, right? And this would be a pointer to an integer. And the features of the pointer, the set of features would be number one, right? This is pointer is a variable that stores an address of another variable. Basically, in our view of memory, which is extremely simple, right? So this is our view of memory. Basically, we have two physical parts of memory which we can recognize. When we create a variable such as this x, its value, which is 0 over here, is placed someplace in this memory location, which was given to variable x, whatever the size of that memory location is, and 0 was stored. And we access this memory location by name, which is x, because we just said, well, look, we would like to have a variable, we'd like to have a name associated with that, and that's variable x. And later on, somewhere here, we can say x equals 5, right? What happens is this number 5, which is hard-coded in some program, replaces the old value, right? So the old value is replaced by the new value, right? So the new value becomes 5. So now x, which is a symbolic name for this memory location or variable, its value becomes 5. At the same time, if this variable x ended up in memory location hexadecimal 0x1234, right? If that was its address, then when we say what's the address of x, basically we're just saying this is the address of x, whatever it happens to be at this time, and so this address gets stored inside a variable named p. So p, which is a pointer variable, gets its value 0x1234. And then we say that we can have variables that basically remember the addresses, right? So we, in C, C++, we have access to both the addresses and the values of the variables. So normal variables hold the values, being double, integer, or some fancy object, right? Whereas at the same time, we can ask any object, what's your address, and remember it in the pointer variable. Okay, so that's what I would like us to basically realize at this point. I already started my Visual Studio, which again I will be using today because just a mere convenience, but in code blocks it's going to be very similar experience. File, new project, right? So we're just gonna start another project today. Let me see. As always, empty project. And this time I will say this is what week, let me actually look this up, what week numbering we've used so that I don't have any collisions. I need my I need my file manager view someplace anyway. So this will be, if we sort it by name or by date, right? So this was week 7. I'll go with week 9. Week 09, and this is going to be a stack demo today. Stack demo. Okay. If you're using Visual Studio in class, make sure that you uncheck those create directory and other options there, because they're just going to make the directory structure a little bit more confusing that you need. Okay, so once I create this empty project, right, I go to View Solution Explorer and Source Files, and I will immediately say Add New Item, because I don't have anything, it's an empty project. Add new item, and I will say give me the CPP file. Of course, it's going to be main.cpp. It's almost like boring because it happens every time we are here in the morning. Source, that's the subdirectory where I'm going to keep my source. Add it, and so the file is created for me. We're just going to say include IO stream so that we can communicate with the world, and we're going to go include cstdlib so that we can use the pause int main, right? So there's a return statement as always, return 0, right? And remember, I always add like an empty line to the ending of my C or C++ file. System pause, and then we're pretty much done, right? So it's just like basic structure of the program. Right away, I'm going to add a header file to my project. Because I would like to start working on a new concept. Essentially, today we're going to explore the behavior of object named stack. Perhaps I can demonstrate before I create my own. I can say include stack, okay? And I can create a stack object which works as follows. Stack, well, we can use stack of integers or stack of characters or stack of strings. Basically, these angle brackets specify the type of object you want your stack to hold. For example, if I want integers, I can create stack st. Okay, so this whole thing here with spaces, I can get rid of spaces if that makes you more comfortable. This is the name of an object. However, all objects in standard library, including cout and cin that we use for input and output in C++, they all located inside namespace named std, which is like a bag of things. So this becomes the actual data type, right? So std stack int is the data type. When these data types become a little bit too confusing because they're so long, one thing that you can do with this, you can say type def this to be my stack. And we can actually give it like my stack. If you did something like this, you can replace this by simply saying my stack. My stack st. That would be the same thing. But I don't think it's really that bad that we need this type def. Type def essentially creates a synonym name for something that already exists. Type defs are popular. Like there could be like really silly type def, like for instance type def int units of measurement, something like that, right? And then you can use units of measurement instead of an int, like unit, right? So you can say int unit, but if you wanted to go a little crazier, you could basically rename an int to be units of measurement, and the compiler doesn't care, right? It will say that anytime you say unit of measurement, it's going to replace it with an int, okay? So this is just a little something that we can observe, that a lot of professional programmers do use typedef to give synonyms to different names. So I'm just going to basically just take this out, okay, and keep it as a comment in case if we need to discuss any of this. But right now I'm just going to go with my default version of the name, which is std, which is the standard library namespace. Stack is name of a class that exists there. It needs to be parameterized by the type you want this stack to hold as a value, and then finally we have the name. Now, what is stack? Right, question mark. So let's discuss what the stack is.